All right. So since we learned a lot of property of linear algebra using Gaussian eliminations, and you'll be really helpful if you can understand them in terms of metric multiplications. We will look at Gaussian elimination again and try to express them as the operation that we do with metric multiplications. Okay, and upon doing that, we will get a way to we get a new method to factor a matrix. Okay, what I mean by factor a matrix is this. So suppose I have a matrix A. Okay, some square matrix. If I can write, so if you have a number like 12, you can say 12 is 3 times 2 times 2, right? So this is factoring a number. Okay, if you have when I say factor a matrix, it's like I write A as some multiplication of two matrices L and U. Okay, and L and U has to be in some form, some nice form. We'll see later on. Okay, and if you can do that, we get what we call an LU decompositions. Okay, LU decomposition has a nice properties, but the whole idea is like we would like to express the Gaussian elimination process that we do, which is a central process when we work on linear algebras using metric multiplications. Okay. Question 2 in the exercise, we actually do that. You don't have to do it now. I'll guide you through it. Okay. All right. So let's have a quick review on what the Gaussian elimination is. Okay. So if you have a system of linear equation like that, like this, we can sort of like write them as a using metric form. So we take the coefficient 1, 1, 1, right? So we write a coefficient as a matrix and we factor out the variables. Okay, and then this is the constant. Okay, so the coefficient is basically this is 1, 1, 1, this is 2, 1, 2. So I write 2, 1, 2. We did this, we already did this, right? 3, 1, 2. Okay. And when we want to work on this, we usually start by focusing on the matrix first. Okay. The right hand side constant are important. They are really important, but not as much. Okay, we look at the matrix first. Okay. When we do the Gaussian elimination, if we do the whole process, we would like to do some as a quick review. Okay. I'll go over that later. Okay. So basically, when we do Gaussian elimination, we would like to change this matrix, right, into some form, a matrix of the form like this. So you have some non-zero value, and then we have some zero value here. Okay. So if we transform the matrix from the top one to the bottom one, okay, and these are zero, we can do some back substitution to figure out the value of these variables of x3, right? So after we know x3, we can substitute into this and solve for x2, and we can substitute x2 and x3 into this equation to get x1, right? So this is what we usually do when we do Gaussian eliminations. Okay, and this matrix has a name. Okay, this is called upper triangular matrix. It's triangle, right? And it's on the top, so it's called upper triangular matrix. If you have a system of linear equations in the upper triangular form, then it's easy, very easy to solve, because it you can iteratively solve for one variable at a time, right? And then you can solve the whole system pretty easily. Okay. So the idea of Gaussian elimination is to to somehow reduce or change this matrix to that kind of matrix. And while you do that, you sort of preserve all the solutions on in this process. Okay, we will try to do that now, but when the way we do it, okay, it's not just we'll do it as what we did previously, but then we'll try to express all the row operations that we have using matrices, using matrix multiplications. Okay, so we do this to get you some familiarity with matrix multiplication. Okay, okay, so it's in this form. Okay, okay. So suppose we have a matrix like this. Okay, when we perform Gaussian eliminations, okay, what do? We basically try to eliminate this two, right? Okay, we do that by, okay, before we do that, suppose the first row is not 1 1 1. Okay, suppose the first row is, so let me change it really quickly. Okay, so suppose the first row is, say, 3 3 3, and this is 30. Okay, it's really hard to do Gaussian elimination because it's not that hard, but it's more convenient if we change this to 1, right? How can we change this to 1? We can just divide the first row by 3. Okay, so after we divide the first row by 3, I can continue my process. So from this matrix 3 3 3 blah blah blah. Okay, what it is it's like I say R1 is going to be R1 over 3, and I get 1 1 1 like this, and the rest of it will look the same. Okay. 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 Now let's try to do it differently. So we do it by instead of writing this. So writing this, let's try to find a matrix that would multiply with 3 3 3, 2 1 2, 3 1 2. Let's find this matrix that multiply with this, and you get 1 1 1, 2 1 2, and 3 1 2. So this matrix is basically perform these operations. Okay. So you want to divide the first row by 3. Okay, but we don't actually do that right away. We want to find a matrix that actually do it. Okay, can you find such matrix? Okay, before we doing that, let's take a look at this. There's one matrix that is really nice. There's one matrix that if you multiply it with any matrix, you get the same matrix back. What is it? It's called an identity matrix. Okay, it looks like this. So if you have 1 1 1, okay, I'll get, if I do this, then I would get the same matrix back. Okay, how can I get the same matrix back? So let's try to do the multiplication a little bit. Okay, so let's focus on the first row. Okay, let's focus on this row. Okay, how can I get 3 3 3? I get 3 3 because the way I do matrix multiplication, right? So how do I do matrix multiplications? So the first row, where the first row from? How do you get the first row when you do matrix multiplication? So basically, you take the first row of the left hand side of the product, right? And then you multiply this with this column, okay? So you get 1 you multiply with 3, and you get this 3, okay? So you multiply with this, and you get 3. Because you have 1 times 3, 0 0, so you get just 3. Okay? How do you get this, the second 3? ตัวที่ 2 มาไงครับ So it's going to be 1, 0, 0 again, and I multiply with this, right? So I multiply, so let me write something small. So 1, 0, 0 here, so I get 3. Okay, and last one, how do you get 3 here? So again, I have 1, 0, 0 times this, so I get 3 here. Okay? Okay, this is review. How do I get the second row? How do you get the second row? So basically, I get the second row because of what? Because this row, right? Okay. I use this row and I do the multiplication again. But because it's 1 here, it's 1 on the middle guy, right? So I pick the second row. Okay, and then I get the second row here. And how do we get the last row? So I use the last row here, right? And then 1 go to all the last row, so I get 3, 1, 2. Okay? Okay, now my question is, if I want to divide the first row by 3, how can I change this identity matrix so that I get that result? How should I change the identity matrix? So I need to multiply, instead of 1 times 3, 1 times 3, 1 times 3, I need to multiply 3 with 1 over 3, right? So this number should be, what should it be? Okay? I put 1 over 3 there, so I'll get 1, 1, 1. All right? Okay, so let's look at problem 2 in exercise 9.2. Okay, you have a matrix A 2, 2, 4, 6, 1, 5, 6, 5, 8, 9. Okay, you would like to divide the first row by 2. Okay, you would like to divide the first row by 2. Can you write down the matrix that after you multiply with matrix A, you divide the first row of A by 2? ทำเลยครับทำข้อ 2 in exercise 9.2. So basically the second row I'm gonna take the second row as well, right? So it's gonna be, so this is like exactly like in the identity matrix, because I don't change the second row, so it's gonna be 0, 1, 0, because 0, 1, 0 just select the second row, and 0, 0, 1 select the last row. So the last two rows remains the same. But I would like to divide the first row by 2. So what should I do? I should put 1 over 2 here. Okay. And then the rest is the same. Okay. So this is what you do. To divide the first row, you put 1 over 2 there. Suppose I want to divide the third row, what should I do? I just put something here, right? Okay. Okay. So when we do the Gaussian elimination, sometimes we like to divide some of the rows. We do it by that. Just multiply it by that. Okay. Today we will not actually try to get 1, 1, 1. We will leave whatever numbers we have, but it's good to know that you can change it to 1 pretty easily. Okay. Okay. After you get to this, okay, what we would like to do next is suppose this is the coefficient metric that we have. Okay. We would like to the second step to do Gaussian elimination, we basically would like to remove this guy, right? We like to remove this guy. How can we remove? Change that to 0. So we basically take this row, right, and subtract it with the first row. Okay? So if we take the second row and subtract it with the first row, we get this. Right? How do you get this? So 1 minus 1 is 0, 5 minus 2 is 3, and 6 minus 3 is 3. So you get this row. Okay? No, when we do Gaussian elimination, this is the process we do. We take some row and subtract it to the other rows. Okay? So the first row, currently we have the first row, and we usually refer to the first row as this variable as the pivot variable. But you don't really need to remember that. But we use this variable to subtract all its component from the other rows. Okay? So to do that, we subtract the first row out of the second row. Okay? So to do this, we usually write it like this: R2 equals R2 minus R1. Okay? But how can you do that using metric multiplication? How can you do that with metric multiplication? So let's fill in the easy part. Okay? The first row and the last row remain the same, right? They remain the same because therefore our metric, when we multiply the metric multiplication, it's going to look like this. So why is that? Because the first row, what should be the first row? It's just the first row of this guy. So when you set the first row to be 1, 0, 0, okay? When you do the metric multiplication, okay, 1, 0, 0 will be you multiply with each of the column here, right? So it just basically take the first row and you put the first row here, so you get 1, 1, 3. So same thing, you get the same thing back. So the first and the last row will be 1, 0, 0 and 0, 0, 1. Okay. Now we would like to modify the second row. Okay, we would like to modify the second row so that the second row becomes the second row minus the first row. Okay, how can we do that? Using metric multiplication. So let's do the easy part first. So if I just put 0, 1, 0, what do I get? I get 1, 5, 6. Right? Do I miss something? So I get the R2 part, right? If I just put, so let me write it in the smaller way. If I just put 0, 1, 0, I get this, right? When you multiply this with all the columns, it will take 1, 5, 6. Okay? But what do I need to get this to be 0, 3, 3? What else do I need? So I need R2 to be equal to R2 minus R1. Okay? What I'm missing here, now I get R2, right? Can I get the rest? What is the rest of the value? It's minus R1, right? So minus R1 is what? You need to multiply R1 with minus 1, okay? So where should I put minus 1 in this row? The first column, exactly. So I put minus 1 here. So let's see. So I put 1 here, I put minus 1 here, and I put 0 here. Then I get that. So let's see how it works. Okay. So let me zoom in by a lot. Okay. So how do we get this row? Okay, I get it by I take this, right, and I multiply this with each of the columns. Okay. when I multiply with each of the columns, minus 1 gets multiplied with this guy, and 1 get multiplied with this guy, and 0 get multiplied with this guy, right? So minus 1 with this. So for each of the columns, I get minus 1 of this first row, and I get 1 times the second row. So I get this. Okay? So to do the row operation like this, okay? To set the second row to be second row minus the first row, one way that I could do that is to just write this. Another way is like I multiply the matrix with that matrix. Okay? This matrix, the result of multiplying this matrix is basically take the first row and subtract it out of the second row. Okay? So you get this matrix. Now, in the last step, I would like to queue this guy, right? To queue this guy, I would like to set R3 to be R3 minus 5R1, okay? What would the matrix be? In this case, what would the matrix be? So let me do the easy part. So the first two rows are the same, right? So it's going to be 1, 0, 0. So take the first row, and then take the second row to be the same. Now the last row, what should I put in the last row? So that the effect will be exactly like this. Okay? Okay, do it. Your time, your turn. ทำเลยครับ Should be easy, okay? So the last row will be, what would the last row be? Be 1 unit of this, and what else? What else do you need? This row. So this row is basically this, right? 1 times 5, 8, 9, plus minus 5, right? Plus minus 5 times 1, 2, 3, right? So this row would be, I put 1 here, and I don't use any of the second row, right? So put here. And what should I put here? What should I put here? Minus 5. All right. So suppose we have this equations, and we would like to perform Gaussian elimination. Okay. The first step is to basically try to eliminate this 2 and 3, right? So the way we do that is basically, since this is already 1, right? So we say we let R2 row to be R2 minus R1, okay? After we do this, we get this to be 0, and then something else, right? And then we do R3 equals R3 minus, not minus R1, minus 2R1. And because this is 2, right? And then I set R3 to be R3 minus 3R1. Okay? After you do that, you get this matrix. Okay? And then what else do we do? So if we want to be real nice, we might want to multiply the second row by minus 1 to get 1. But here, don't do that. Okay? It will complicate something later on, so just leave minus 1 there. It will be a little bit harder, but things will be cleaner this way. Okay? So how we want to eliminate minus 2 here. How can we eliminate minus 2? So we multiply minus 2 to this row and add to the third row, right? So we set R3 to be R3 times minus 2 R2, right? So you multiply minus 2 to that and add to this, you can kill this guy. Okay? After doing that, what do we get? We get this matrix. Okay? And then I multiply minus 1. So just leave minus 1 there. Alright, so after we get this one, this matrix, it will be a nice matrix for us because it's upper triangular. Okay, as I told you before, triangular matrix is nice for us if you want to solve linear equations because we can do what we call back substitution. So we can solve for alpha 3, right? And then after we know alpha 3, we can substitute and solve for alpha 2, and then we can back substitute and solve for alpha 1. So when we have upper triangular matrix, our life will be much easier. Okay. Now, so this is what we do when we perform Gaussian eliminations. There are 3 steps here. Okay. The first 2 steps is this one. Okay. And the third step is this one. And we get this. Okay. Now, what we will do next is that we would like to do the same thing here, but instead of writing down as row operation, we will find a matrix that do that for us. Okay, we find a matrix that after we multiply the matrix with this matrix, we will get the effect of row operations. Okay, this matrix will be referred to as elementary matrix. Okay, so let's see. Okay, so so the first step is to do this, right? If you recall. So we like to say R2 to be R2 minus 2R1, right? How can you do this with matrix multiplications? So we have matrix A. What matrix should be we use to multiply with A to get this result? Okay, this is the same thing that we did, right? So after we do this, the first two rows are the same, right? So 1 1 1, 3 1 2, and let me remove this. 2 1 2. The first 2 rows are the same, right? So I get 1 1 1 and 3 1 2, right? So here, what should I put here? The first 2 rows should be 1 0 0 because this row basically, when you do the matrix multiplication, would basically pick the first row. Okay? And the last row will be 0 0 1 because when you do the matrix multiplication to get this row, it will pick the last row. Okay? You multiply 1 1 1 1 and 0 on the others, right? But the second row, we would like to take it to be the previous value of the second row minus 2 times the first row. So what should we put there? You want 1 unit. So here, you want 1 unit of R2, right? So it should be 1 here, right? We don't want the third row, right? So you put 0 there. And what else you need? You need minus 2R1, right? So you put minus 2 here. Okay? After you put minus 2 there, when you do the multiplication, what will we get? So let's try to do it. So you get minus 2 times 1 plus 1 times 2, so you get 0 here. Right? And here, you take 1 minus 2, so you get minus 1. And then you multiply minus 2 here, and multiply that to get 0 here. Okay? So that's what you get. Okay? So this one, we refer to this one as the elementary matrix. Okay? Because it basically represents the row operation that we've done. Okay? So this is the first step. Let's call this matrix M. So this is A, I call this M. Okay? M times A, and you get that. Okay. So the next step, we would like to eliminate the last row. Right? How can we do that? So we have this matrix. We've done so far, we got this 1 1 1 0 minus 1 0 and then 3 1 2. Okay? And we want to find a matrix that after you multiplied it, okay, the first row remained the same, 1 1 1. The second row remained the same, 0 minus 1 0. But the third row is gonna be the third row minus 3 times the first row. Okay, so let me fill the easy part, 0, 0, 1, 1, 0, 1. And what would be the last row here? What should the last row be? I take 1 unit of the last row, right? So it should be 1 here. Do we need the second row? No. What else? Minus 3, right? So I get this to, after you do that, you get this. Okay? Alright, so you sort of know the procedure now, right? Okay, so let's try. If you do it again, I need to eliminate 2. Okay? So after you do that, so I have 3 matrices, M prime, and M prime prime. So in the exercise, I call M1, M2, M3. No, E1, E2, E3. So we will look at that soon. Okay? So after you do 3 matrix multiplication, you get the upper right triangular matrix like that. Okay? We will write it down like this. Okay? We write it down like this. So this is the first step. Okay? We'll do that with the let's do that in the exercise. Okay? So you do the first one, and then the second one we'll just do this. Okay? So we have one row called operations, and leave this one out for now. So work it in 3 columns. Okay? And then to do the full Gaussian elimination, you will perform 3 steps. Okay, so let's try to do the first one together now. So let's do this one first, so that we can get started. Okay, so the coefficient matrix, right? And then we have 3 variables: x1, x2, x3. And this is equal to 7, 8, 9, and we basically just mostly ignore this. Okay, this one we ignore, so it cry out. Okay, but that's okay. And then the coefficient will be, what are they? It's going to be 1, 3, 2, 5, 10, 1, and then 2. -4, -4. Now, after you get this done, we'll do the Gaussian elimination on this matrix. Call this A, call this one A. Okay? So the first step, you would like to eliminate 5, right? To eliminate 5, what are the operations that we do? We say R2 equals R2 minus 5 R1, right? And then do the operation and get the result. So write down the resulting matrix here. It will be the first row remain the same, right? So I write some of them. 1, 2, 3. And then this one will be 0. And then you have something else. Okay. And the last row will remain the same. You have time to work on it, okay? Don't be hurried. And then after that, keep doing that, okay? And you say R3, it's gonna be R3 something, right? And then you have another metric here. And then finally, and then you do something. The last step you do something, right? And then you have the last matrix here. And this last matrix will look like this. You have 0, 0, 0, and then you have something. These are non-zero. So this is the upper triangular matrix. Okay? Do this. And then after this, this is just Gaussian elimination. Okay? Don't try to be clever at all. Don't try to scale the row to be 1. Just ignore it. Okay? Just make sure that you get all the thing right. And then now, okay, so the new part is here. After write down this matrix, or we perform this operation, right? You should write down the matrix that, let's call, I call this E1, E12. So let me check. It's the same. Yeah, E12. So E12 is going to be the matrix that after you multiply this matrix with A, I get this. Okay? So E12 is a matrix that represents this operation. Okay? It will look like 1 0 0 0 0 1 because the first and the last row is unchanged, and this part is, you need to figure out this part. Okay? Also here, figure out this matrix 1 3 E13. E13 will work exactly like this. Okay? And it will look like the first row will be the same, the second row will be the same, and the third row is something that you need to figure out. Okay, call this E13. Okay. And finally, you need to figure out the last step. Last step, you say R3 equals something, right? So this is going to be called E23. It's the matrix that after you multiply with the previous matrix, it performs exactly like this one. Okay, it should look like the first row will be the same, and the second row will be the same, and basically the third row is something that you need to think about. Okay. All right. So you sort of understand what you should do now. First of all, you have this matrix. You want to perform Gaussian elimination on this matrix. Basically, you start by perform 3 row operations. Okay, don't scale any row, just keep it like that. Okay, you don't have to make them 1 1 1. You just make them 1 and some numbers. Any numbers is fine. Okay, so the first step, eliminate the second row, the first column in the second row, and then the first column in the third row. So perform 3 row operations. Okay, 1 2 3, and express each of the row operation as a matrix, like that. Okay. After you get to this, you're halfway done. Okay.